Okay, welcome back, everyone. We are very timely. It's only 3 minutes after the top of the hour. Quick note, if you bought a t-shirt and you haven't received it yet, the next break would be a really good time to pick it up. I will be out there and I'll get it for you. But that's my only announcement. So let's get started. You ready, Garrett? Okay.
It's nice to see everybody again. I'm going to try to keep things relatively light since we're working off lunch. But I'm Garrett Nelson. I'm the president and head curator at the Leventhal Map and Education Center at the Boston Public Library. Today's talk actually in many ways reflects my own sort of split institutional identity. I'm the person at the center who's responsible for our digital collections and geospatial resources. But I'm also the curator of the collection, so I have to put materials in front of patrons in physical and digital exhibition spaces. I also sit on the history faculty at Northeastern University, where I teach classes in digital public history. And then finally, I run a small nonprofit where I have to tell donors and funders and institutional partners why we're doing the things that we're doing. So today's talk is an attempt to take the technical and digital architecture of a geographically integrated map collection, digital map collection, and in particular, the unique possibilities of the All Maps IIIF collaboration, and set it into a series of sort of so what questions. Why should we bother to do this? I'm starting from a kind of supposition that predates certainly All Maps and really predates even IIIF, which is as map collections started to become among the first major visual collections to get digitized in institutions. Quickly, collections managers began to think we should georeference everything. We should, any time we have a digital collection that has a map on it, we should georeference it. That's a part of digital infrastructure for reasons. Sort of if you're familiar with the Edmund Hillary, we climb Mount Everest because it's there. This was a bit of a, we should georeference the maps because it's possible to do it, and let's do it because it's impressive and a kind of technical doodad. I'm trying here to get beyond that sort of technical doodad. We can georeference maps, therefore we should, and try to instead to lay out not just the technical ends, but the sort of perspectival, scholarly, interpretive, and pedagogical ends that justify the investment in a IIIF-powered georeferencing system, not only institution by institution, but in a larger ecosystem of digital objects which are georeferenceable and potentially in conversation with one another. First, a little bit of cold water or devil's advocate about georeferencing. The pat answer for why should we georeference something in our collections has long been, we can layer it on top of a modern map. This has been the sort of end user use case for georeferencing for many years now. And I want to say a few things about why that's actually not always the best thing to do. This is an early 20th century map of the United States from our collection, which has been georeferenced. This is All Maps Viewer. It's beautiful, but it really doesn't add that much in this case. Certainly our audiences, this is one of the most familiar geographies to them. We didn't really need to put this map of the United States on top of another map of the United States in order to realize this is a map of the United States. There's a few little things in this 100-plus-year-old map. The Dakotas are a single state. But I didn't really need to get it here. I could have shown you the original untransformed map, and people would have still been able to kind of slot it into a modern geography pretty well enough in their minds. So this is the additive value of seeing this on a modern map is negligible zero-ish. Here's a case where it's actually, I would say, degrades the experience of seeing a georeferenced map. This is an early 18th century map of Boston, one of the first European maps of Boston, French map of Boston. It's so inaccurate in the original that transforming it and warping it into a modern map distorts it beyond legibility. So, do I have a cursor up here? The Charles River is completely missing on this map. There's actually a river here. It's not on the early 18th century map. So we've actually made the map worse here by layering it on top of a modern map. So these are two cases where that kind of default, like we'll georeference the map so that we can show it in a modern map viewer in Web Mercator projection. has not done anything for us. It's, in this case, actually made the collections worse. So I'm going to attempt to give a set of other answers of why we might georeference and what it does for us, not just as collections managers, but my background is as a historical geographer, really how it draws users of all kinds into new kinds of questions, ways of engagement about space and place, which connect the map to other sources, other experiences, other forms of inquiry. The first of these is actually a bit of a contradiction in my title. I titled the talk after georeferencing. This is actually sort of before georeferencing or during georeferencing. And it is the act of georeferencing itself as a valuable addition to the suite of tools that we can ask people to engage with our digital collections. This is one plate from a city atlas of the city of Worcester in Massachusetts. You can see it being georeferenced with control points being added in All Maps Editor. This is a project that was just done the past few months by a student intern working with us who's actually a Chinese national, very unfamiliar with Massachusetts as a geography, but now is probably one of the top 20 experts on the city of Worcester in the entire world. And he actually had a chance to go visit Worcester, to walk around, to visit the public library there. And it was a sort of like an amazing experience even just to watch from afar. This person had never visited the city, but knew its historical geography intimately from this manual process of looking up points on the old map and matching them to a modern web map. I've done the same exercise with students of all backgrounds. We do this with even K-12 students in some cases. And so actually asking people to do the work of georeferencing is valuable beyond the data that it gets us. It is an exercise which has a utility in and of itself. Part of what I promised here is some sort of, not only why we do it, but also how that might feed back into the technical architecture of the system. Here's a case where we're really excited about being able to sort of version and sandbox georeference annotations. So we might want another student to go georeference the same map, which has already been georeferenced. In this case, we'd have to just delete the existing annotations out of all maps. We've done some work on just creating like a dummy manifest for students to work with. But we're hoping to get to a point where we could say stand up a sort of like sandbox environment for students to work on a georeference annotation that's not ultimately going to come back into the repository of record. Another thing that we can do, especially as we georeference collections at scale across institutions, is that we can compare historic map collections not to the present day. So we're not layering old map on top of 2026 map just to compare what's here now to what used to be there, but we can compare past to past. This is in some ways the equivalent of comparing different states of a single document, whether they're older photographs of a manuscript or spectral imaging. But because we have the place as the sort of spatial index linking these collections together, we can bring them into conversation with one another across collections types. Here you're looking at a custom viewer we built for our City Atlas collections called Atlascope. In the center is Copley Square. You can see the Boston Public Library peeking out on the left side of the sort of porthole there. And that's a 1902 City Atlas. In the background is an 1885 City Atlas before that building was built. So this is a really neat little, we're seeing before there, this is a neighborhood that was built in the late 19th century. See the neighborhood before the library was built. We see the neighborhood after the library was built. In this case, these are both maps from our collections, but this particular viewer also has collections from our partners at the State Library of Massachusetts. We are beginning to be able to put, for instance, items from the Library of Congress through their IIIF endpoints. And so, taking two objects from two completely different collections and using them to tell a diachronic story about historical change is a really, really powerful learning tool, visualization tool. And of course, we can layer upon layer upon layer, think about these objects in correspondence with one another. Another thing that we can do is to bring historic map collections back into larger digital portals in a way which makes non-cartographic materials more legible and interesting as spatialized objects. this is a photograph of a building that doesn't exist anymore. It's one of the original buildings of the Massachusetts Institute of Technology, formerly our neighbor in the Back Bay neighborhood of Boston before it moved to Cambridge. You're seeing this photograph in our federated Massachusetts collections portal called Digital Commonwealth. And on the right is the, if you scroll down, the metadata entry for this particular photograph. And it's got just a sort of bog standard blacklight map index plugin. So you see where this location is tagged on a 2026 or whatever, whenever these OpenStreetMap layers are vintage of map, which is not actually very helpful in this case because that neighborhood doesn't exist anymore. We're working on a plugin for the collections viewer that will say, let's place this object not on a map of today, but on the closest available map we have to the date of the object itself. So this is a 1905 map. You're seeing here in our atlas viewer, that's 1908. That's the building. That's the right of those two pink buildings is the building that you see in the photograph viewer. So now we've created a whole new set of map indexing tools that can be used to give more relevance and more historical context to the original photograph collection. And we can imagine doing this for all sorts of other material, including, not necessarily image collections like photographs, but even things about people's lives, timelines. Instead of having to rely on modern day maps as the only types of digital maps available, we're now building a huge potential library of historically indexed maps of the past that we could use as our base layers instead for those kinds of projects. Next is the way that taking a geotransform map, set of maps, putting them into conversation with one another across kind of linked spatial context enables a set of storytelling and narrative opportunities, which are really powerful for both students and for public users encountering the collections. What you're looking at here is one of those same city atlases in Boston's Charlestown neighborhood. These are screenshots from a sort of story maps-esque interface we built called Panel Truck to wrap IIIF images and map layers. I think in some ways that may be superseded by the work that the All Maps team is doing around narrative storytelling with maps, but this is a thing that exists that we can put All Maps and other georeference materials stuff into today. And this is a graduate student project just from this past term where the student has started, in this case, with a, just before, I think this is a 1930s map of the Naval Yard. They've moved over onto a aerial photograph from the mid-20th century. In this case, they're telling a story about a public housing project in the neighborhood that it replaced. They're zooming in and then going back to the map, again, using this kind of diachronic but spatially synchronized storytelling tools to jump from map to collection, back to map, and then later on in this same story, they bring in images and other kinds of collection objects and place them on the map and build a story out of that. The sort of beautiful story about Leiden that we saw in the All Maps presentation yesterday is a version of that, where we're taking the map as a way of jumping out into a whole set of other collections objects. So we can only do this because we have transformed the maps. We could have done it with just an ungeoreferenced plate by plate, image by image set of maps, but the ability to synchronize them together in a spatially indexed way makes this kind of narrative form possible. Finally, and I will say this is the thing that I personally am most excited about, is going backwards rather than taking collections objects and warping them into the geometry space of a modern web Mercator projection. What we can do already with some of the tools available in All Maps is we can take modern spatial data and project it backwards into the pixel space of the map. That's very easy to do with points, for instance. So this is All Maps here, a fun tool that the All Maps team has built where it will query your location and then show that location on whatever georeference maps exist in All Maps that contain that point. Here I'm confessing that I was finishing this presentation from the airport. That pink dot is the location of Terminal E in Boston Airport. And this is actually an amazing story right here. The airport is built on mud flats. This is a late 19th century map of what was called Noddle's Island, the former marshy quasi-island that was eventually filled in the early 20th century to build Boston's International Airport. This is a much more interesting way to see that story than taking this same map and warping it and stretching it. It gets quite warped and stretched in order to put that on top of a modern map of the airport. Instead, I'm inviting the user back and to say, this is the place. This pink dot is in exactly the place where I was sitting in the terminal. It's on the edge of this marshy landscape that's just being bought and speculated upon. In terms of what we already do with paper collections, I could stand in front of this actual collection in our classroom and ask people to say, where do you think the airport is? And then, point a laser pointer at it and say, that's where the airport is. This is doing that in a digital interface that is allowing us to take what we know about the present and map it back onto the past. There's all kinds of things that become possible when you do that, and we're really only beginning to experiment with this. Here's a 1776 map of Boston. This was actually made by a British loyalist who was given permission to survey the city in great detail when it was under siege by the British. And we have reprojected the modern street grid. So this is just arterial roads in Boston, reprojected onto that 1776 map. It's cool. On the left is the sort of, wow, this is cool. This is the streets of Boston. But there's also sort of like real substantial historical geographical stories that one can extract from this. On the right, you're seeing a zoom in. This is our, horrible highway American interchange. And you can really see how it was built on land that didn't exist in the 18th century, right? And this is like a huge aha moment for students, right? Why is there an interstate highway and a big flyover and an interchange there? Well, it's because this area was not developed until much later in the 19th century. It literally was a harbor in 1776. And again, this is a much more effective way of doing that than taking the old map and kind of warping it out of its original dimensions and plopping it on top of a Web Mercator projection. Here's another example of that. This is an unrealized plan for the Back Bay neighborhood. The red outline is the sort of major street that the library is on, and we use this in a project around how did this neighborhood get built, and that same geometry we showed over and over and over again on historic maps that were never built for this neighborhood, and using it as the sort of spatial anchor to connect these collections together. So this is really exciting. In some ways, I think it's a much more intriguing visual tool than the standard take the map and make it modern. Let's take the modern data and make it historical. Finally, and I really want to leave this as a bit of just a kind of jumping off point. That's why I've labeled it point infinity. Making map collections geospatially integrated offers all kinds of possibility in terms of thinking about map collections as big data sets. This is our own version of the same, you saw the pink outlines in Burton Jules' presentation yesterday. This is specifically the maps in our collection that have been georeferenced in all maps. That's the whole world. But beyond this, just kind of like boggle your mind, look how much is in here. There's actually some interesting questions we can interrogate from these finely demarcated polygons around georeferenced maps. We've had bounding boxes for a decade or more, but this much more intricate and precise geometry can answer questions for us like, how did the cartography of an expanding city change over the 19th century? Actually, as I was making this, I was starting to think like, I should do this animated by time so we could actually see how different parts of the city are getting covered cartographically as we move through the 19th and 20th centuries. I actually did some stuff with like a point cloud to look at for any given point in eastern Massachusetts, how many times was it mapped across like a constrained period of time. And that's to say nothing of the things that we can look for, annotate, transcribe within maps once they've been georeferenced, and then be able to locate that within the actual world space of a modern coordinate system. So this is a whole nother talk, right? Thinking about large corpus map collections as big data sets and what we can do with them, how we can interrogate them. But the process of georeferencing, the process of creating a standard, for instance, like in the georeference IIIF annotation standard, opens up all these kinds of possibility. I'm going to leave it there. Thanks to the IIIF team for a great conference so far, and looking forward to answering questions.
Hello, everyone. It's a pleasure to be here. It's my first time in this conference. I'm learning a lot from all your projects and developments, and I'm here to present to you how we have been using IIIF for researchers in the natural and engineering sciences, specifically how the IIIF can become a practical research infrastructure for data-intensive science. My name is Leila, and I'm speaking here also on behalf of Gabriela Kuhn and Jules Hosman, I don't know, who is, they are also part of this presentation and project. This picture here depicts the TUDEF library, where 4TU research data, where I work, is based on. And this is showing a beautiful and rare summer day in the Netherlands. Yeah, really suspicious picture, but it's real. Yeah. So I will start by telling you what is 4TU research data. And we are a data and software repository tailored to the natural and engineering sciences in the Netherlands, and our services are more also tailored to the 4 technical universities depicted in the map. Delft is the leftmost. We have Wageningen in the middle, then Twente University, and in the south, Eindhoven. And our mission is to enable researchers from science and engineering and design to make a global impact with research and data and software. And just to go to also our main drivers of a repository, is that we provide a trusted research infrastructure to improve also digital skills for researchers through training. And we also spend most of our time developing tools that enable the findability, accessibility, and interoperability and reusability of data and software to improve transparency, integrity, and impact. And for us, it's also very important digital sovereignty. So through collaboration, we want to preserve control and ownership of our infrastructure and data. So our main service is the repository of data and software, and it has an open infrastructure. It's based on an open source backend that supports open protocols and standards. And me, I'm Leila. I'm the trainer and coordinator of digital skills at 4TU Research Data. So I would like to present, this is the landing page of our repository. And here you can see some, the pointer doesn't work. Okay, some statistics of our data sets. So we are hosting close to 12,000 data sets, and here you can browse data sets from different institutions and subjects. So now I will present you like a use case of a researcher when they come to our database that is not for only depositing data. They, for example, they would like to compare, for example, a microscopy image, a specific output, a specific analysis from the image with an image from the database. So they can go to a repository and they can say, okay, I would like to see a microscopy image from super resolution microscopy, and they go to the website and then browse this term as a keyword, and then there are some hits, and then they found what they want to see and they want to compare, and then here you have like a landing page of a data set in the repository where you can see the title, we have a DOI, the authors, the description of the data set, the format, and what are the publications associated with this data set. Here you can see the keywords, and the format is a TIFF format, so it means they are images. So and when the researcher goes to the files and the data they would like to check, to compare with their own results, they found out, okay, has like 29 gigabytes. So then that's the first pain that we face, which is that scientific images are often large, heavy, and multi-resolution, and they are technically accessible but not operationally usable. So usually the workflow will be like they will discover the data set, they will download the files, they have to store it locally, and then analyze it. And this prevents many researchers to do this. So this is one of the reasons why we, last year, we implemented IIIF in our repository. It's in-house, so we have our own image server for IIIF. This is the first and obvious reason for using IIIF that is also very relevant for research. That is by serving the images with IIIF, then we are turning them into queryable resources to enable, for example, the remote computational reuse without imposing the download requirement. So in our landing page of the same data set, we provide this IIIF manifest that we create in our backend. And then the researcher can open, in this case, we use this manifest editor from the Geographic, but we don't prescribe any viewer in our landing page, so it's a preference of the user to use any viewer they want. But in this case, okay, they can open this microscopy image, super resolution image that has 4 gigabytes. And then with that URL, they can go and in any cloud computing, remote cloud computing environment, they could retrieve that image and make some analysis and compare with what they have and see if they agree or not with the results, right? So this is really a really nice use case that IIIF will shine. And ideally, what we would like is this workflow that you have the viewer of the depiction of the image, and the researcher kind of drop a box or a region where they would like to do an analysis, and then call or suggest a cloud computing environment to perform analysis on that region, and everything on the cloud, on the fly, without any download requirement. This is one use case we want to explore and keep developing in our repository. The second use case I want to bring is okay, after the researcher is looking at the images in a viewer, they may wonder, okay, I want to understand what is the geographical, let's say, and temporal context of this data set. And currently, at 40 research data, the metadata in the manifest is fixed and limited. And researchers can view images, but they cannot easily understand the geographic or temporal context. They cannot compare experiments. They don't have enough metadata for that currently. And discover, for example, related publications related to these images, videos, or any other kind. So we propose to have a dynamic enrichment of IIIF manifest from repository metadata. So we have, for example, we have this data set on training data of semantic segmentation of historical images, which contains historical images from the Antarctica, made from 1940 until 1990. And they are made to train software on discovering which of the elements are present in the images, either ice, snow, rocks, water, clouds, sky, etc. So this data set have geolocation, and it contains 5 gigabytes of data. And the format is also images on TIFF. So we can load the manifest, and we can see in this same viewer, let's say, these images, but currently, as you can see, the geolocation is not recognized in the manifest, so we cannot directly see the location in the model map. And the only metadata that is exported, let's say, to the manifest is about the title, the authors, and the description. So it's quite limited for comparing experiments, for example. So one thing we can do is we can dynamically enrich the manifest from the repository metadata, and we can get this metadata from the data set via the API of our repository. So we can kind of have a tool or a plugin that take all this metadata from the data set, and we can allow the reuser to select which metadata they would like to see in the new manifest. Then we can inject it in the manifest, and then this enriched manifest is potentially now ready to be reused by external tools like all maps. And now, when that gets enriched, for example, with resource DOI, which is like, these are links of the papers that this data set is related to, so it's enriched, the context of the data set is getting enriched. We can see also the location in the map pointing to the Antarctica. Now, when this geolocation is transported into the manifest. So this same data set has been also used for all maps to georeference these images from the Antarctica into and overlay them in a modern map. After listening to you, there are many other reasons to do that, not only to overlay on modern maps, but the point is that by enabling this enrichment, you add value to the data set, and you enable that workflow as the reuser wants to do. So also, like, this would be like the dream, like to have this landing page of the data set, and then we have a manifest, let's say, and created by our backend. And then we can have a tool that still allows the enrichment of any type of fields the user would like to do, to see, in a viewer. So apart from these use cases, of course, integrating IIIF in 40 years data resonates with our main drivers, and especially with reducing the dependency on proprietary visualization platforms for the images. And for the first time, we can think about aggregating different research outputs from different institutions of the same research topic, let's say, and compare different images as the same you are currently doing with the cultural heritage museums collection from different places. We can think the same for research outputs, and it will certainly add a lot of value, and it's not possible to do it. We have also other opportunities with IIIF and for researchers, which is we can enable them to publicly outreach through reusable digital collection. We can transform scientific image data sets into shareable digital collection for education, communication, and public engagement. Also, we can make research repository landing page. We can improve the data set exploration through inline image previews, thumbnails, and interactive visualization directly within the repository interface. And of course, all these cool things impose for us a lot of infrastructure and metadata challenges. And one of them we can think of is that we have to prevent in the repository that researchers deposit in zip folders. So when the data is in a compressed folder, of course, any of the images or things are exposed for the IIIF API to recognize it. So this gets hidden and they cannot be reused. So this is one thing we have to work on. And also about the metadata, that we currently don't have file-level metadata, so the geolocation is at the level of the data set. But if in the data set you have multiple images referring to different places, that they have different geolocations, we currently cannot tackle them. So it's like just one global coordinates. So this is one of the challenges. And the other one, which is also very important for us, is that currently we don't have an efficient caching for fast dynamic rendering of large data sets. So it could get really slow on loading them in the viewer. So the IIIF APIs run inside 4TU research data Python backend, and that turns this repository into an interactive image service that, of course, it needs efficient rendering and caching. And this is another challenge that we have. And just to finish that, I would say that IIIF for us, for researchers, and I guess for everyone that uses, is not only a visualization layer for repository, but it can become an operational infrastructure for scientific reuse, interoperability, and computational access to image-based research data. And with that, I would like to thank you all for your attention.
Hi, good afternoon. My name is Richard Palmer, and I'm technical lead in the digital media team at the Victoria and Albert Museum in London.
And I'm Zoe Hollingworth, the Collection Systems Lead in the Collections Management Department at the Victoria and Albert Museum in London. Today we'll be speaking to you about how we utilized a feature in our digital asset management system, or DAMS, to aid with manifest generation for our collections.
And there's going to be lots of this alternation, I'm afraid, sorry. So I've presented before on how we've been implementing IIIF at the V&A in an incremental manner, persuading an internal audience of the benefits of carrying out, I don't know what's...
I tried to move the slide on, I'm so sorry. Thank you.
Okay, I'll start again. So I've presented before on how we've been implementing IIIF at the V&A in an incremental manner, persuading an internal audience of the benefits of carrying out the slow, and forgive me Zoe, but not necessarily exciting, system-level changes that are needed. As part of this campaign, we developed a variety of features on the website demonstrating some of the exciting opportunities provided by IIIF, such as annotated zoom and deep zoom and slideshows with annotated images, which were all used for content features to accompany exhibitions we held. Then the creation of manifests of volumes highlighting some of the treasures in the National Art Library, such as this botanical album presented in Universal Viewer. And leading up to the most complex work we've recreated, which is a volume with pages now held across multiple institutions. And so far we've been able to unify the pages and the half pages that are held between the Victoria and Albert Museum and the British Library, and there may be more to follow at some day. So this all looks very nice, and it did the job of persuading people that IIIF is a good thing, but the reality is the manual work behind the scenes for creating the manifest for these features has involved spreadsheets, emails, phone calls, meetings, final spreadsheets, final spreadsheets, some cheap champagne for the launch, and then some more emails and spreadsheets for any corrections after the launch. So this very manual process led to the decision to stop with the shiny features for a while and switch instead fully to the infrastructure work needed to make this all a much easier process by making use of our existing DAMS system as the place where the knowledge for a reconstruction would be created and maintained, from which we would then programmatically retrieve this data and generate the IIIF manifest from it.
To do this, we first had to work out what was needed for encoding in our DAMS the knowledge required for creating a manifest. That way, curators could create the knowledge in an internal system, and we could then retrieve it from there to generate the IIII manifest. For deciding on what we needed to store, we went through examples of items in our collection from the simple, such as a letter with just a few pages in sequential order, like this example, to the more complex, such as the Teutonic Knights Bible, as mentioned before. And then on to more complicated examples, such as Leonardo da Vinci's notebooks, which are, unsurprisingly, nightmares to document. So going through a variety of items, such as those, and what data would be needed for the manifest for them, this gave us the overall requirements to take to our vendor to discuss how this could be implemented as part of our dams. And so, as Richard mentioned earlier, the previous process has been overly complicated, hence spreadsheets and spreadsheets and spreadsheets, both for our curators who want to take advantage of IIIF and the digital media team who were having to deal with the endless spreadsheets, saved to local drives, resulting in a lot of manual effort. With our digital asset management system, though, we identified the underutilized project functionality, which in essence allows our users to group digital assets together, but we had no defined output or procedures for actually how to use this functionality. So we went ahead and discussed these opportunities with our dam supplier and our key stakeholder, Catherine Ivyard, who's the curator who looks after our special collections in the National Art Library, including the aforementioned notebooks of Leonardo da Vinci and the original handwritten manuscripts of Charles Dickens' works, including David Copperfield, Bleak House, and Oliver Twist. So first we worked with Catherine to carve out the metadata requirements, the title of the project, the viewing direction of the pages, what information should be visible on an image, and how to reorder those images simply, either by using data sets like system ID, original file name, description, or even manually. So this process went through several iterations, as you can imagine, of testing with Catherine to ensure she was happy with how it worked and understood how to add or remove digital assets from a project. Crucially, we needed to ensure that any metadata fields that we created could be picked up through the API, which Richard will show you in a moment. Once we updated our live system, Catherine was able to create projects for the various Charles Dickens manuscripts in the NAL collection.
So you can see here a beautiful example of some of the JSON data that we retrieve from the DAMS API, which tells us the basic project information that we would need for the manifest generation. And then separately, but not on here because it would fill the slide, would be all of the sequencing information with the DAMS asset IDs, which we would then retrieve and make available on our image server. So together then we would have the manifest and all of the images to make the manifest work. But for people who don't like looking at JSON, like Zoe.
Don't take it personally, that's fine. By the way, this is one of my favorite objects in our collection. It's very cool. The letters and numbers are hand added by the artist. Anyway, look it up later. Yeah, so here's a screenshot of the same project dams with those fields that you saw in the previous slide in the API, indicating the type of project, viewing direction, viewing experience, and hopefully if you're a curator or a librarian, you can appreciate it's quite straightforward. You can also indicate whether you'd like it to be deep zoom. It's not represented here, but that is also one of the options we've included for metadata. And it's from here you can also sequence the images from this screen. And here you can see there's a few reordering options on the far right. You can reorder by the asset depiction, asset ID, and original file name. And then also you can sequence manually from the left-hand side with kind of arrows or just moving things up and down. And then the user also has the option to include an alternate label if they'd like. So when it appears in the manifest, there's a little bit more detail as well.
So we finally now have the ability to generate the IIIF manifests at the push of a button from the information entered and managed in our dams. This means a curator can create a digital facsimile of an object and view it without even having to offer me a glass of English sparkling wine. At this point, I would love to say that we could show the manifests on a live site, but we haven't quite got there yet with the launch of our new archive site. that would show some of the manifests that have been created for volumes in the archival collections. But we do have an example that has been created in this manner, which is a 17th century book on how to make purse strings, volume 1 of 6 volumes, just to point out. And it has example purse strings attached, which would be a nice modeling problem for either the 2.5D, 3D, or moving books group, or all of them, I'm not sure. So this was requested by researchers, and they wanted us to send it to them in some form, so a PDF was possible. And previously, though, that would have required a lot of work, as mentioned, to create the sequence, to generate the manifest, to turn it into the PDF. But now the creator, Catherine, could sequence the images in the dams. We could retrieve the sequence and the project information through the API, and then we turn that into the IIIF manifest. And then we ran the script to turn that into a PDF. So it now becomes a much easier process and all automated, except, I'm sorry, curators, someone still does have to do the sequencing somewhere. And so that now at least happens in the dams where that data is maintained and other people can see it and make corrections or have different sequences if they have a different opinion on the reconstruction.
So for the future, looking ahead, digital media, as Richard has said, are developing the designs for how IIIF projects will display on our website and explore the collections. We've also been exploring other use cases, particularly photo albums from the Royal Photographic Society. There's currently a project digitizing that entire collection. And the Wedgwood Majolica pattern books, which again is another collection we purchased in 2014, and they are gradually digitizing it. We're also hoping to integrate image textual annotations with our dam supplier. It's a feature that exists, but it's not quote unquote turned on yet. And how this could be implemented retroactively for some of the V&A's research projects. We obviously have a lot of students coming through and doing a lot of work, and we want to be able to utilize that research and add it into our system. A couple examples of these are the Da Vinci notebooks. We've had several researchers, as I'm sure you can appreciate, very interested in those notebooks. And there's also been a fantastic project, the Chinese iconography thesaurus project, which would also make use of those annotations. There's also been some interest originating from our South Asia Gallery redevelopment, which reopens in spring 2028, to make objects in the physical spaces more accessible to wider audiences.
And though we've been trying to move forward incrementally in our implementation from the simple, as I mentioned, slowly through to more complex, I remain unable to resist thinking about the nightmare examples. So I'd be keen to have some chats on digital reconstructions with anyone who has items in common with us that we could create a manifest from. And I've put some examples and people or organizations there. If you want to come and say hello, if I don't already know you. But if you know of anything as well, it would be great that we could combine them and create a manifest reconstruction. We would then have to work out how we would store that structure within our dams, and I do wonder at this point what that structure would be, because we'd more or less be recreating the data structure of IIIF to be able to store that within the dams. So I think that's a bit of an open question of how complex we need to get, but that's a problem for the future.
Yeah, I'll just finish by saying thank you very much for listening to our presentation today. We hope you enjoyed hearing about what we've done and also the beautiful pictures that I've inserted into this presentation, forced into this presentation onto an unwilling Richard sometimes. But it's such a nice picture, come on. And we look forward to answering any questions at the end of this session. Thank you.
Good afternoon, everyone. We are Ilya and Mario, and today we will present you our digital variants edition, featuring dynamic highlighting of text on a facsimile in one or more parallel IIIF viewers. We are working for KANTL based in Ghent, Belgium. We are working in a very nice building, as you can see on the logo. KANTL is both an academic society as well as a cultural heritage institution. And we are focusing on promoting and studying Dutch language and literature both in Flanders and the Netherlands. Within our digital department, we develop applications around historic text corpora as well as scholarly text editions. Many of those are letter collections or variant editions. The latest one of those is Elias, which is integrating TEI and IIIF in a digital environment for studying text genetics. The subject of this is Elias, which is a modernist novel by Flemish writer Maurice Gilliams, who wrote this in the 1930s, but continued to work on this novel and make revisions throughout the rest of his life, resulting in more than 40 versions and with more than 10,000 differences across all of these versions. The novel is featured in the Canon, which is a list of 50 most essential works in the history of Dutch literature. It is being refreshed every 5 years, and it is also compiled by our organization, KANTL. The origins of this project are a PhD thesis by Lisbeth van Melle, who made an analog variant apparatus as well as an early attempt towards an electronic edition documenting the genealogy of Elias. Of course, we could not have made this edition without the very start, which is the very famous first sentence of Elias. Here we see it in a manuscript from 1930. The very same sentence we see here in the paper variant apparatus of the already mentioned doctoral thesis. And then in 2017, an early prototype was encoded in XML-TEI, which happens to be the default encoding standard we are using for all our digital products. Here is an example of how the variants are actually encoded in XML on a sentence basis. And this is then how this is finally rendered in our edition. In order to get IIIF manifests as well as high quality scans, we were happy to collaborate with two partners. On the one hand, Ghent University Library, who kindly provided us with all the printed edition scan material. And on the other hand, Letteren based in Antwerp, which is a literary archive for all the manuscriptal material. Getting all these extra interesting materials finally led to a drastic expansion of the prototype, and we had a full release of our digital edition end of last year. It features 12 milestones, which are like the 10 authorized printed editions, a typescript, and pre-publication in the edition, which are the basis to compare across all of those versions listed there. Okay, here you can see the text. If you hover over it, you see the difference with other versions. Click on a sentence, and the sentence is immediately highlighted in the viewer. You can open a parallel viewer comparing it to other versions. You can filter on variant types, dynamically click other versions. Everything is nicely aligned. You can also dynamically select variants to compare against. Click it away, switch perspectives easily, browse through the entire novel, click another sentence, it's highlighted again. Finally, we have a search function, returning a quick formatted list, bringing you directly to the text string you were searching. The edition is embedded in a larger web environment, presenting also a facsimile library of all the sources we have available. Here you can see it. So you can browse through that timeline. You have next to it the facsimile, a number of metadata with some clickable links to the manifest, to our TI source, also some tooltips with descriptions taken from the metadata. And then you can use the viewer with all basic functionality, browse through the novel linearly, or go directly to the chapter you want via the chapter shortcuts. All in all, this is a very useful environment for students and literary researchers in order to study the relation between the printed editions and the underlying manuscripts without having to dive into physical archives, libraries. Here you have all the sources around this novel in one place. This is an example that shows that we need a bit of magic in order to do that highlighting thing. So this is a mixed typography of a TypeScript with some manual annotation corrections from the author. The principle of doing the highlighting is based on the comparison of two text strings. On the left, you see this is the ground truth, text extracted from our TI coding. And on the right, you see the OCR rendering, which contains some mistakes. And those two need to get aligned. The OCR is downloaded as in Alto format, which does not only contain like the text orthography, but also the coordinates in the OCR and some word confidence scores. And there you see in red already a few examples where it goes wrong. Not surprisingly, parts where the author has made the manual corrections. Then the alignment procedure is taken, sorry, I'm a bit nervous. To a large part is carried out offline. So for both left part and right part, what happens is that the text is extracted page per page. And then for each page, all sentences are extracted again. And per sentence, all sentences are tokenized. And for every word, starting from the ground truth, we compare it with the OCR. We compare with a maximum window of 3 OCR tokens. The reason we do that is to capture also some anomalies. Like we have the hyphenated words at the end of line. We have word contractions, etc. So that way we can match them. The best match is obtained via a scoring mechanism, taking into account a number of features, such as word confidence scores, string similarity, the position in the reference versus the OCR position, and a match is only considered successful if the score exceeds a certain threshold, otherwise the word is skipped and rejected. The result of this is a word mapping table with ground truth word indices associated with OCR coordinates. And from within the online application, the word positions in the table can be retrieved via search API, of which you will hear more later. And this finally results into drawing the bounding boxes and doing the final highlighting. Okay, we did also a bit of QA on the highlighting, of course. We managed to find potential alignment errors by using different techniques, such as finding overlapping alto coordinates in the OCR output, by finding word position outliers, for instance, by comparing the word character length versus the width in the coordinates found in the alto, finding extreme long white space, etc. We also looked at the non-matched ground truth token positions. What was the problem there? And after any changes to the scoring function, we also did some regression testing to make sure that in the mapping table no unintended things were introduced. Finally, there was some spot checking done by an intern who is studying comparative literature, and she also found a number of additional problems. A nice bonus of this QA procedure is that we managed to find a number of unintended errors in our edition by looking at the remaining mapping issues, actually. So now my colleague will tell you a bit more about the architecture of the tool.
Thank you, Mario. Hi, everybody. For the architecture of the digital edition, we used an open source XML-based database, namely Exists, that renders our client from the XML TEI source code. At the bottom, you can see a small snippet from this source code that is then converted into HTML using XSLT scripts. That HTML is then styled using CSS and controlled using JavaScript, which you can see the end result of in the edition. For the IIIF architecture, we used a KANTL image server to serve all our images in the manifests. And we also converted the TIFF scans we got from our partners of the books into JPEG 2000, using open JPEG to save some space, of course, on our server. In the client itself, we use Mirador as a IIIF viewer, but a very stripped down version of it. Why stripped down? Because we didn't want to confuse our users with too much functionality. You maybe saw there are already a lot of buttons in our edition, so we try to keep it to a minimum. But instead, we just control Mirador rather, using JavaScript fully. Now, a big part of the edition was that we needed to find a way to align our HTML and the IIIF. And namely, when you click on a certain change, we need to be able to tell Mirador, okay, open this certain manifest from a version, and also navigate to the correct page that sentence is on, and also, of course, highlights that sentence. A quick demo from in the edition. You click on the change, the left panel renders the correct version, and then in the overview, you can check the sentence of the change in all the different versions it is located in. Mirador renders the correct window and also navigates to the correct page. To realize this, we tagged each change with the version it is on and the page number that is related to it. We then use these two values inside our manifest as a sort of anchor. So each canvas has a canvas ID, of course, and we then use these two values inside those canvas IDs to make sure we have a unified way to control Mirador and send it to the right version and to the right page. Now for the highlighting, we created a custom implementation of the IIIF search API. We used Elasticsearch to do this. That is a search and analysis engine that contains the whole mapping index my colleague mentioned earlier. And then we use FOSS API to actually enable all the API endpoints and handle all the search logic. Now I'll take you in a quick day in the life of a IIIF search query. You can see a small screenshot from our edition. When you click on the change, JavaScript extracts the text, page, and version that is relevant to the change. In this case, the text you can read, the page is 19, and the version is D1, the first official version of the book. This is then passed to our search API. The search API receives it. It then first retrieves the relevant index entry for that version and page. It extracts all the text coordinates for the highlighting, and it then builds the annotation, the IIIF annotation list, and returns the results. So this is passed back to the client, JavaScript passes it to Mirador, and then we get the highlighting you saw in the edition. Thank you very much for your attention, and we kindly invite you to check out the edition via this URL.